This video is an exclusive excerpt from our latest FSW webinar. If you're interested, the complete replay is available for free by following the link in the description. Have a nice viewing!
Hello everybody, we are more than happy to welcome you to today's webinar about friction stir welding defects. Today's webinar will be hosted again by Laurent Dubourg, CEO and co-founder of Stirweld with 20 years of experience of friction stir welding. So Laurent, I'll let you present the webinar and I wish you all a great time with us today.
Thank you, Tiffen. Good morning. Good afternoon and welcome for this webinar about friction stir welding defects. So for beginner, I'm going to use a lot the acronym FSW for friction stir welding. And today the topic of this webinar is what are the most common defects in friction stir welding. So some slide about the FSW specifications, how it works, because it's important to understand the physics behind the tool to understand the defect appearance. What are the welding parameters and the impact on the defect? We don't have time to develop this chapter 3 about clamping jig design. So it's a very, very important point, but this is I need at least 4 hours only dedicated to jig design. And I will finish by introducing the main FSW defect. So today it's only 1 hour about overall training of 2 days. I'm sorry for that, we don't have time for that, but if you want to attend this complete training, don't hesitate to contact Tiffen here or Ornella in USA to attend this complete 2-day trainings. So basically, we can say that we have 4 families of welding parameters, or 4 criteria for high quality weld. The tool, so depending on the weld penetration, depending on the material, we'll use different tools. So on the right, you can download our FSW tool catalog. And so you can see the different our families of FSW tool. The second criterion is the welding parameters, traveling speed and rotational speed. Criteria number 3 is the force control. So I will speak later on during this webinar. So we apply a constant pressure during the friction stir welding process. And the last criteria is the clamping system itself. That is very important because friction stir welding process it's a wonderful and a perfect process, but there is one problem: is the process doesn't like a gap. So that's why the clamping system must be very strong and important to avoid any movement during the friction stir welding process, and to not to create a gap between the parts. So that is very important. Okay, so now let's go about FSW tool specifications, how it works. As I mentioned previously, any friction stir welding tool is composed of 2 important parts: the shoulder here and the pin here. So the shoulder is placed on the top surface of the part, and by friction between the tool, the shoulder and the part, we create heat by friction. And the second part, the pin, plunge into the piece, and thanks to the rotations of the tool, stir the materials. So the shoulder creates the heat and soft the materials, while the pin stir mix the parts together. So that is basics, but in fact physics it's a little bit more complex. So using this simulation, we can learn a little bit more about how the heat is created into the materials. So into this simulation, so you can see a tool here. So it's just the half parts of the tool to limit the calculus. So you can see the tool here. You can see an aluminum part here. And here you can see different values of temperature. And so for this emission, we consider only the tool friction. And so we learn here that the main source of heating is the contact between the shoulder and the top surface, and also the contact under the pin. But now, the second source of heating is the plastic work. So imagine that the material turns around the tool, and so in fact we have very intense plastic works. And this plastic work creates also heat. So we can simulate. So here we only simulate the heat coming from the plastic work. And as you can see, we have about 100 degrees C here, and also it's very, very hot under the pin. So now we can sum these two phenomena, and we get this result. And first learning, the optimum temperature is about 400 degrees C, and the hottest zones are under the shoulder and under the pin. But now, if we look to the input energy, in fact, the main source of energy input is under the shoulder. But what is interesting here is about 70% of the heat generation coming from the tool friction, and about 30% coming from the plastic work. So in fact, it's not only due to the friction. The main is friction, but 30% is coming from plastic work. And the second learning is the optimum temperature for good stirring is about 400 degrees C. That is very important for the rest of my presentation. Okay, so now let's discuss about the welding parameters. So for that, I like to use these drawings where so we have this graph here, where on the vertical axis we have the rotation speed, and on the horizontal axis we have the welding speed. And so we can sum up using three zones, three process windows. The first one here is what we call a cold weld. We have a cold weld when the welding speed is too high or the rotation speed is too low. So this is obvious. Less rotation, less friction, and a high welding speed, a low energy input. So that's why this zone is called cold weld. And this cold weld is characterized by a porosity into the weld root. So in fact, so it's not a punctual porosity, it's a continuous porosity. That's why we like to call this defect a wormhole, because it's a continuous porosity. And this continuous porosity, this wormhole, appears in the weld root. Why? Because if I go back here, so in fact it appears just close, not under the pin, just above here. And it's where we have the lowest temperature. So if the temperature is too low, generally under 350 degrees C, the material is not soft enough to be stirred by the pin. So that's why, in fact, the material is too hard, and so the pin cannot mix the material. So that's why we have this continuous void. So that is the cold weld. Now, on the opposite,
there's still 30 minutes to watch. Access
weld.
the full video for free by clicking the link in the description below. And don't forget to subscribe to our channel to learn more about friction stir welding.